Hello students, today we'll talk about the force experienced by a straight current carrying wire when placed in external magnetic field. We know that whenever we pass current through any conductor, it produces its own magnetic field, and when this magnetic field comes in contact with the external magnetic field, there should be some attraction or repulsion. So how do we determine this force of attraction or repulsion? That is the topic today. So we have one equation and we'll see how to use it. So let us consider first a current carrying wire. Say I have a current carrying wire and the current through it is passing like this. Or else you may consider a current carrying wire having current going in negative x direction. So in this case, at different points, how do we have the magnetic field? What is the nature of magnetic field around the wire? So if I consider, say, 4 points A, B, C, and D. Earlier also we had discussed that if you want to determine direction of magnetic field at A or B or C or D point, what you have to do is you can use right hand thumb rule. So how do we use right hand thumb rule? So what you can do is keep your finger, keep your right hand thumb in the direction of the current, and then you can see that the curling of your fingers will indicate direction of magnetic field around the wire. So for the considered case, this is how curling will take place, where with the point say curling of finger will be like this, and that indicates that when I have the current passing through the wire, above the wire fingers are coming out. So at point A, I can say that magnetic field at point A is in the direction of positive Z, isn't it? That is plus B K. But what if I am at B point? At B point, fingers will be going down, and hence it is negative y direction, so minus b j cap. What about C point? Fingers will be going inside, and hence it is negative z direction, so minus b k cap. And behind the wire, fingers are upward, so B D is plus B j cap. So this is how you can find out direction of magnetic field around the wire. Consider second case. So again, let me consider 4 points, say A, B, C, and D. I want to determine direction of magnetic field at these 4 points around the wire, and I know that the direction of magnetic field is in negative x direction. So what should I do? So again, curl your fingers around the wire in such a way that your thumb is in the direction of current. So here what you can do is, if you curl, the fingers will be like this. So you can say that above the wire fingers are going inside, isn't it? Fingers are going inside, and hence at magnetic field direction at A point should be inside. So B A is in negative Z direction, so B A cap. What about B point? B point is in the front part where magnetic field lines are going up, so plus B J cap positive Y direction. At C point, fingers would go down. Behind the wire, fingers would be going down. and hence it is negative y direction, so b j cap. And what about d point? At d point, if you are, the fingers will be coming out, so positive z direction, so plus b k cap. So this is how you can determine direction of magnetic field around the wire at different points. Now let us see the formula. Formula says that now if I consider that I have magnetic field produced by some magnets. Say I have a north pole here and south pole here. And between this magnetic field, I place a current carrying wire. Say current is I. So what should happen now? Now the wire has its own magnetic field, and I have external magnetic field also. So there should be some attraction or repulsion, isn't it? And that attraction or repulsion force should be experienced by the wire. So how to determine that force? That force is given by this formula IdL cross B. This is the formula which can be used to find out that force. So let us try to apply that formula. So in this case, what I have to do is, first I have to determine what is the IDL. So I can say that the current is going in positive x direction, so it is IdL I cap. Okay. What is the direction of magnetic field? Magnetic field is always from north to south, so it is negative y direction. I can say that it is B, j cap with negative sign. And then if I find out force, the formula says that I should take IdL cross B. So IdL I cap cross minus B j cap. Now what is I cross j? It is K, and negative sign as it is, so it is I B dl k. This is the nature of the force experienced by the wire. So you can say that the wire will bend outside. Positive K means the wire will bend like this in this direction, coming out of the uh, plane of this screen. Uh, what will change if you consider this situation? Look at the next figure. So now I can say that my IDL now is in negative x direction, so minus IDL I cap. Magnetic field is still going down, so I can say that B is still minus B j cap. Again apply DF, which is IDL cross B, and then I'll have minus IDL I cap cross minus B j cap, and then you will get DF to be plus I B dl k cap. Sorry, so I made mistake earlier. It is not k cap, it is negative k cap. So this wire will experience force in this direction minus k cap, whereas here the force will be plus k cap. This wire will try to come out the plane. So this is how you can determine the force direction, and you can do practice by considering two more cases. You can consider that the magnets are kept like this. So what is the magnetic field direction? It is coming out, okay, and between these two poles I have a wire carrying current like this. Or else you may consider that the wire is like this and magnetic poles are like this. So what is the magnetic field direction? It is from north to south, positive x direction, and the current ITL is coming out. See, dot is indicating that current is coming out. So you can say it is ITL K cap. Okay, B is uh, B I cap. In this case, B is B K cap and current is ITL I cap. So you can consider different possibilities and find out the nature of force every time. Okay, so try out the two in your homework. So that was the topic, and in next video session we'll apply this formula and we'll find out force between two wires carrying current. Suppose you have two wires, say this case, there are two wires and both are carrying current. So both will have their own magnetic field. So would there be attraction or repulsion? And if attraction or repulsion, how much and how do we determine? That we'll see in next session. For now, this is all. Thank you.